morning, welcome to new lecture. Today I will look at the influence line for girders and trusses. Generally we have slabs and the dead load and live load will transfer first to the slab, then slab will transfer to the beam and those side beam will transfer to the girder. So I can write here generally the floor loads, it means all dead load and live load, are transmitted from slabs to floor beam then to side girders. In most cases we have a slab, we have joist or small beams, then we have girders. So if I show in 2 dimension, it will be something like this. This is main girder. For example, we have support here, roller, and we have here one hinge support. On top of this girder, perpendicular to this girder, we have joist or floor beams. And on top of this joist, we have usually slab or different kind of structural member, usually slab. So first, dead load, live load will transfer to this joist and joist will transfer to this girder. If we want to draw influence line for the girder, for example this girder, assume these are 10 feet each. A, B, C, D, E. And here, for example, we want to draw influence line for shear in the panel CD. Panel CD, this panel. So, draw the influence line for the shear in panel CD of the floor girder. We want to draw influence line for this girder in panel CD. It will be exactly same as we draw influence line for the beam. First we will draw influence line for shear. Because it is panel CD, we will draw in the midpoint of panel CD influence line for shear. It means we will cut, we will put this system, then we will move up, we will move down at midpoint of the panel CD. In that case, what will be the deformed shape? Deformed shape of structure will be something like this. And because this is midpoint, if midpoint 10 feet each side, it will be 5 feet, 5 feet. So each part will be 5 over 10, 0.5, 0.5. But now our traveling load moves here in the slab. So we should modify this influence line. We will transfer this point to the influence line. Point A will be here, point B will be here, point C will be here, point D will be here, point E will be here. Now you see a panel or slab between these points. From D to the E we have one panel. We will attach using one straight line. From C to D we have another panel. So we will attach these points using one straight line. Again BC, another line, and AB, another line. Then from similar triangle, if this is point 5, you can find this. From similar triangle, if you find it, it will be point 33, and this height will be point 33. So the influence line, if our load moves here in the slab, will be this one. So the extra part you can remove it, delete it, or you can keep it. But I am making this part as bold. So our real influence line will be this part. You can remove or you can keep this part. This will be influence line for girder if we have joist and these kind of panels. Transfer these points to the influence line, then look at to this panel to see from A to B if it is one line, attach one line. If it is continuous from A to C, attach from A to C, and so on. So it is easy to figure out. Let's look at to the next one, for example. Next one, we have simply supported beam. This is girder. And 1, 2, 3, 4, 5 panels we have. And these are our joist and slab from A to B, from B to C, C to D, D to E, and E to F. Again, the distance between these joists is 10 feet. We want to draw influence line for shear in panel CD, A, B, C, D, E, F. Panel CD means this panel, shear influence line at midpoint. So from 5 feet from C, 5 feet from D at midpoint, we will put shear connection. Then we will move this side up, this side down. What we will have, the deformed shape of structure according to the Muller-Breslau method will be influence line for this girder. So because this is 5 feet, 5 feet, each side will go up and down 0.5. This will be 0.5, this will be 0.5, because this will be B over L. If this is B, B over L, A over L. Now, we will transfer these points to the influence line. Let's show with another color. Point A, point B, point C, point D, point E, point F. Then there is one slab between E and F. From D, E, another one, DC, CB, and EA. This will be influence line. From similar triangle, again, it is very easy to figure out. This height will be 0.4, this height will be 0.4. So the influence line, if our load moves here in this slab level, will be this one. Influence line for girder at panel CD if our load moves on slab. Extra part, you can remove it. Let's look at to the moment at point E. Moment at point E, you will put hinge here, rotate like this. In that case, this will move up. This height will be, if this is A, this is B, it will be AB over L. L here, 1, 2, 3, 4, 5, 50. 10 times 40 will be 400, times 50 will be 8. This height, this angle, it is unit angle, 1 radian. Point A is here, point B is here, point C is here, point D is here, point E is here, point F is here. So if you attach these points, you will get the same shape. So this shape will be influence line for moment. This will be shear at CD panel. This will be moment at point E. Let's look at to the next one. A, let's see, A, B, C, D, E. Distance, each one 4 meters. We want to draw shear influence line for panel BC. So shear influence line for panel BC at midpoint of BC. We will put shear connection up, down. If we move this part, if we shift it up and shift it down, the form shape of structure will be like this. Then we can find these parts. Each one will be 0.5. Then we will transfer to here. Let's see. Then we will transfer A to this point, B to this point, C to this point, D to this point, and E to this point. We will attach using a straight line. So again, this will be the influence line at point at panel BC for shear. Shear influence line, panel BC. Extra part, you can remove it. And from similar triangle, you can find those heights. So, let's see next example. If you find using similar triangle, let's say like this will be 0.25. This height will be 0.5. You can find it because you can find this one and this one. This one will be 6 over 1, 2, 3, 4, 16. So this one will be 6 over 16. This one will be 10 over 16. 10 over 16 and 6 over 16. So from similar triangle, this will be 0.25, this will be 0.5. Okay, let's look at the next example. Influence line for truss. Influence line for truss. Let's look at two very simple truss like this. Okay. A, B, C, D, E, F, G, H. We want to draw influence line for this truss at support A. If we draw influence line for truss support, it will be exactly same as influence line for beam. So you will remove this support, you will shift up 1 unit. This will be influence line for reaction at support A. Influence line for reaction at support F. Again, you will remove this support, you will shift up point F, 1 unit. So this truss, the form shape will be influence line. So if we draw influence line for support reaction, they will be identical as a beam. But let's look at today influence line for members. Here, because truss member, in truss member only we have one internal force, and that is axial force. Bending moment is equal to the 0, shear force is equal to 0. So whenever we draw influence line for members, we should draw for axial force. Let's look at today, for example, influence line for member CD, this member. Member CD, I want to draw influence line for axial force in that member. The easiest way to put unit load in different point, for example, in this truss, traveling load move on top side of the truss, so one time you will put unit load magnitude is equal to the 1 at point B, you will find internal force at point CD. You will show here the magnitude. If you put load here, internal force here, it is 0. So that is point 0. Then you will put unit load here at point C. You will find again axial force in member CD. Magnitude of that you will show. If you apply unit load here, definitely it is compression, so negative here. Then you will put at point D. Again you will find another point. You will put at E. Again you will find axial force at point CD. Another point, you will attach these points. This is very easy way, and very precisely you can draw influence line for axial force in truss member. This is one way. But if you want to do faster, of course, depend on the truss shape. Sometimes if you do faster using Muller-Breslau method for trusses, it can be complicated and you can end up with a wrong result. But if you practice a lot, you will figure out. Using Muller-Breslau method, you should remove this member because you are drawing influence line for member CD. You will remove it. You will apply load in this direction, unit load in that direction. What will be the deformed shape? If you apply load instead of that member in this direction, this part will rotate respect to the F and point G will move down. This part will rotate respect to A and point G will transfer here. The deformed shape of truss will be this shape. Deformed shape will be this shape. Now you can attach this point and this will be influence line for truss. So you will say, okay, this is influence line for truss because moving down it is negative. How you will find this height? In order to find this height, like bending moment at point T, this is 3, this is 6, 3 times 6 divided by entire length, which is 9. This will be, let's see, this will be 3 times 6 will be 18 times 9, this will be 2. Then you will divide that by the height of the truss. So 2 divided by 3 will be 0.66. So this height will be, if this is A, this is B, will be A, B over L, entire length, divided by H, the height of truss, H. So you will find 0.66. That is one way to find that. Another way, you can put unit load in the peak point of the influence line, here point D, and find the axial force for this member. If you put one unit load here at point D, the axial force at that member will be 0.66. So this is another way to find that height. Let's see influence line for member. Let's see, A, B, C, D, H, G. So let's remove this. influence line for member at G. Okay, if you want to draw influence line for member at G, one way again, put unit load here, find the axial force in member at G, show here. Next time put unit load here, find axial force in this member, show in this point. Put here, find axial force, show here. Put here, find axial force in this member, put here, attach together. That is one way. Another way, remove the member at G, apply load in this direction, look at the deformed shape of structure, point C will move up and this part will rotate respect to F, this part will rotate respect to A. Again, what is that height? That height will be, this is A, this is B, will be A times B divided by L divided by H. That will be 0.66 again. This time is positive because if your load, traveling load, moves from B to E, always the force in this member, axial force in that member is tension load. For that reason it is positive. If traveling load moves from B to E, the axial force in member CD, always it is compressive load, so it is negative. So the member CD, always it is under compression if load moves from B to E. Member HG, it is under tension. Okay. Let's look at two other members. My recommendation for truss, always move traveling load to different joint and find axial force. Then using Muller-Breslau double check, that is better. That is better. But now we want to draw influence line for member CG. For member CG, again, you can put load at point B, C, D, E. For each one, at B, you will find axial force. At C, find axial force. D, find axial force. E, find axial force. Show these points here and attach together. That is the best way. Or you can remove this member, apply force in this direction, deform shape of the structure will be this kind of deformation. So you can draw influence line using Muller-Breslau as well. In that case, this height, if, let's see, this height, if this is B and this is A, that height will be B over L times 1 over cosine alpha. Cosine alpha, alpha will be this angle of inclined or diagonal member with vertical direction. This is alpha, this is alpha. So this height will be B over L times 1 over cosine alpha. You can prove this using analytical methods. And this height will be A over L times again 1 over cosine alpha. You can follow Muller-Breslau, then put load in different joint and find axial force and compare. So this will be influence line for member CG. Okay, let's look at the next example. we have this beam. Six feet, 3 feet, 3 feet, 3 feet, 3 feet, 8 kips, 12 kips, 12 kips. Point A, B, C, D. We want to find reaction at point A using influence line and moment at point A using influence line for this beam. So we want to find reaction at point A using influence line for this beam under these loads, and find the moment at point A using influence line for this beam under these loads. Reaction at point A means we will remove the reaction. This part will move up. If that part moves up, this up to B will be straight line. B, C, D part will rotate respect to the C. This will be for reaction at point A. This will be 1, 1. From similar triangle, this height will be 1 over 2. And from similar triangle, this will be 1. Positive, 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 negative. Moment at point A. Moment at point A, we will draw influence line for moment at point A. So apply this rotation. If we apply that rotation, point B will move down. This part rotates respect to the C like this. From here to here it is 6, because this angle should be unit angle, so this height will be 6. From similar triangle, you can find this height will be 3, this height will be 3, and this height will be 6. Now, if we want to find the reaction at point A, multiply this load to the height underneath of that. 8 times 1 plus 12 times half minus, because this is negative, 12 times 1. Answer 26 kips. So under these loads, the force reaction at point A will be 26 kips. Moment at point A, load times to the height underneath of the load, 8 times negative 3, because this is negative, 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 positive. Load times negative 3 plus 12 times negative 3 again, 12 times negative 3 plus 12 times positive 6, 12 times positive 6. Answer will be moment at point A under these loads. Okay, thank you so much for watching this lecture. See you next session. And in next session again I will cover more examples for trusses. Thank you so much. Have a nice day. Bye.